Today we're looking at rewriting expressions, and your learning target is I can rewrite expressions to help solve problems. Please take a moment and write your learning target in your planner on either today or the next available date in your planner. And then please note that you will need a pencil and two different colored highlighters for this lesson. So before we jump in, we're going to look at these opening questions. So why do I need to rewrite expressions? Well, here's an example of an expression. It's -3 plus 8. And if we're doing -3 plus 8, we need to remember to add the opposite and figure out how to solve this problem. Well, one benefit of rewriting an expression is that we can rearrange these problems. So we've got a -3 and a +8, and we can just rewrite that as +h, keep the signs with it, plus -3, or if you're adding a negative, it's just like subtracting, so 8 minus 3 is 5. So in this case, the benefit of rewriting an expression is that it's a little simpler to understand. 8 minus 3 is 5. But what about this problem? A store is having a you pay only 80% sale. Well, A, that's a lot of words, and B, it doesn't totally make sense to the people, the audience who they'd be advertising to. It's the words here, you pay only 80%, is confusing. They're trying to say that they're having a 20% off sale. And so it's instead of you pay only 80%, they just say 20% off. Okay, so those are two examples of why rewriting expressions can help you, and they can make things a little bit easier to understand. So your definitions that you need to know for this lesson aren't truly definitions, they're just more so reminders. Percent increase is also known as a markup, and a decrease is also known as a discount or markdown. So here's our first example, and it's to make a profit, a store manager must mark up the prices on the items he sells, which, think about it, that makes sense. If the manager buys a pair of shoes for $10, he can't sell them for $10 because he won't make a profit. He needs to sell them for more than what he paid so that he can make money for his store. So that's what the first sentence is explaining. And then it says a sports store buys skateboards from a supplier for S dollars. And they're just using S as a variable. So don't let that confuse you. This is just your variable. And the store manager decides to mark up the price for retail sale by 42%. Retail sale is what we pay, is what the price that the customers pay. So it's going to mark it up, which markup is a percent increase, and they're marking it up by 42%. Okay, so those are the important pieces that we need to know from this word problem. Then if you're following along in your book, we are on page 63, but just remember you cannot write in your book. So this is the bar diagram that they drew, and right here, this is the original cost of the skateboard. So this is S dollars because this is one skateboard, so it's just the price. From here to here is the price. And then this purple shaded portion right here represents 42% of the original price. And then because the store manager is marking it up, that means he's adding it on to the price. So he's finding 42% of the skateboard, and then he's adding that same 42% to the original price. So this also is 42% right here. Okay, so this whole bar is 142% because this is 100%, and this is 42% of the original skateboard. All right, so basically this is saying the purple part is 42% of S, and of means multiply, and S is the price of the skateboard. Okay, so 42% of S is this purple part, but this is not the full expression that represents the final price of the skateboard, because we have to add whatever this is, whatever this turns out to be, we have to add that to the original price of the skateboard. Do you follow that? So here's the original price of the skateboard. In order to figure out how much we need to add onto it, we need to find out what 42% of that skateboard's cost is, and then add it to the price that the manager paid for the skateboard, so that way he makes a profit. So the retail price, the price we pay, is going to be the original cost, which was S, plus the cost of the markup. Well, the markup is this part right here, the 42% of S. So 42% of S, and then it says combine like terms and write the expression as a single term. So before we can do that, we have to ask ourselves, how can we get this percentage to be a number that we're typically used to seeing inside of expressions? And remember that 42% is part of this expression, but we typically don't see percentages inside of expressions. So we need to use what we learned last week and change this 42% to a decimal, because we're used to seeing decimals inside of expressions. So we take the percentage, move the decimal over 2 times, so now it's a decimal, 0.42. So now let's look at what our new equation would look like. It would be the price we pay is S, that's not a 5, S, plus, well, 42 times S, or 0.42 times S, is just 0.42 S. And now that we have this, can we write this as a simpler expression? Can we somehow combine like terms? Well, remember, like terms are terms that have the same ending or the same variable with them. So here I have an S and I have a 0.42 S. Well, remember that before, if I just have a variable by itself, it's like there's an invisible 1 here. I usually try to dash it so I remember that there's a 1 right here. So I've got 1S because 1 skateboard plus 0.42, remember this was the percentage of the skateboard, or 0.42S, is going to equal the price that I pay. So now that I can see I have 1S plus 0.42S, my final cost is going to be, the final cost I pay is going to be 1.42S. And I got that by adding 1.00 plus 0.42 when I combined like terms, and that gave me 1.42S. Okay, so this is my simplified expression. And then below on your practice, it asks you only one question, and it's about this problem. It says, what are the benefits of writing the price as the sum of 2 terms? So what is the benefit of writing it like this? And what's the benefit of writing it like this? Why might it be helpful to write for the manager to know that this is the equation or the expression? And why is it helpful for us to know that this is the final expression? There's not one correct answer for this, so just see if you can write 2 sentences on why this is helpful. I'll write a 2 here so you remember. 2 sentences on why that's helpful. And then we're going to move on to our next example, which is Keely is selling bicycles, and for the holiday sale, she will mark down each bike's selling price by 24%. So remember that a markdown is a percent decrease or a discount. So for this one, her markdown, according to the problem, is 24%. So we've got 24%. And what you need to know is that the bar from here to here represents 1 bike. So from here all the way to here is 1 bike. And she's going to mark it down by 24%. So this space right here represents 24% of the total price. And it's asking us to find out an expression that represents this sale. So we don't know the cost of the bike, but we know that it's going to be marked down by 24%. So go ahead and shade this box whichever color you would like to. Mine's going to be purple. So This is the amount that we are taking off of the price of the bike, which we don't know. So for the price of the bike, I'm going to use the variable B, and I'm going to use a capital B. So we're going to have the price of the bike, the amount that we are going to pay as the customers, is going to be the price of the bike minus the price of the discount, which is 24% of the price of the bike. Of the price of the bike. Of means multiply. And again, we want to simplify this expression, but we have a percentage in here. So we need to change that 24% to a decimal. So we've got a 24% and we want to change it to a decimal. Move that over 2 times. That changes it to the cost we pay is B, oops, that's B minus 0.24B. Sorry, I'm writing on that black line there, but it's 0.24B. And then we can combine like terms. And remember that a B without a number in front of it is just like having 1B. So I've got 1B, I'm going to do my math right here. 1B minus 0.24. Line up my decimals. Please don't forget to line up your decimals. And we just subtract and solve to figure out how many B's we've got left. So 0, 9, 10. 10 minus 4 is 6. 9 minus 2 is 7. So 0.76 is how much we've got left. So the final price we pay, I'm going to have to write it here. I'm running out of room. The final price we pay is 0.76B. Because this is 24% less than the original cost of the bike. So 0.76B. Okay, so we're going to be doing a lot more of practice with these in class tomorrow. And please come to class with any questions that you have. And if you need to, feel free to watch this video again.